additional block of pointers which is on the disk. So it has to use another block with more pointers. So that's the disadvantage of this method. Okay, so let's look at directories. So this is how we would implement the files. Now the directories are similar to the files. We consider the directories as files in themselves. So let's see how we would implement directories. So when the file is open, the operating system uses the path name to locate the directory entry for that file. Remember, the path is part of the file name. So to open the file, we would use the name and the path. And the path will show us in which directory the file is located. So when the file is opened, the OS uses the path to locate the file. And more accurately, to locate the directory entry for that file. The directory entry provides the information which is needed to find the disk blocks for that file. What information do we need? If we're using contiguous allocation, we need the number of the first block. If we're using inodes, we need the inode. Each inode has a number. So we would use the inode number for the particular file. So the main function of the directory system is to locate the information that is needed to find the disk blocks for the particular file. So it maps the file name, which is usually in English text or ASCII, onto the information needed to locate the disk blocks. Otherwise, where would we store the attributes? So we're using directory to locate the disk blocks of the file and sort of a mapping between the name of the file and the blocks that comprise this file. So how about the attributes of the file? Can we store the attributes also in the directory entry? Yes, we can. So let's see here. We have the file name and the attribute in the directory entry. This is if it's fixed size entry. So the directory entry can be of particular size. Let's say 255 characters. Is that a good idea? What if some file that has a shorter name than 255 characters? So it can be either a fixed size, so we can have a pointer to another structure that contains the attributes. And this way, the pointer is always in the same size, so we're not wasting space. So if we can either have a fixed size or we can have a data structure that stores the attributes. This is for the attributes. Now, for the name of the file, particular operating systems allowed up to 8 characters. So let's say MS-DOS used 8 character names. Back then, the Unix allowed 14 characters. If we want to have longer names, we can either use a fixed size, which means if the file name is shorter than the allowed size, we're going to be wasting space. So we'll have some empty space and waste memory. Or we could create a fixed length header and a variable size file name. So there are 2 ways to handle that. One is in a directory. So we have the attributes, then we have the name. the end of the file name, and there could be some wasted space here, or empty space. And this is in a directory inline. Or we could dynamically store the file sizes on a heap. The file name sizes on a heap. So we have a pointer to the first file name, and then the attributes follow, then the second pointer to the second file name, the attributes of that file, pointer to the third file name, which is foo, and it ends here. This is if we want to have variable size names without wasting space. And the last thing that we will talk about is about the structures of the file systems that we have. So we have several types of file system structures. Log structured file system, or LFS. This is an innovative file system which was designed at Berkeley to alleviate slow disk time. And it works pretty good. However, it's not used much because it was not compatible with all the rest of the systems that we have. And because it was not compatible, then they didn't use it. Otherwise, it's a very good file system. Journaling file system. This is used by so we had here file 16, file allocation table 16, we had file allocation table 32 for Microsoft, and then we said the Microsoft moved to the new technology file system, NTFS, which is a journaling file system, and also the Linux ext3 used that. So what this system is doing, it keeps a log file. It keeps a log of what the system is doing before it does it. Why would it do something like that? So it's about to make changes, create files, directories, set attributes, or anything else that it needs to do. It creates a log before it does it. more effectively managed. Look at these three operations. It's trying to delete a file, it has to call three operations. What if it was on the first step and there was a power outage? Or there was a blue screen and the system crashed. So it's going to ignore the first operation. So it either completed all the three steps to the end, or it doesn't complete anything at all. So it keeps these steps in a log file in case. So if the system crashes, it can resume. We can also have virtual file systems. So if you think about it, the physical file systems are here, and we can have a virtual system which